doesn't necessarily need to be defined. Rate of change is the rate at which something changes. If it's constant, it's called slope. So we're going to start with slope. And slope is a ratio, which if you remember from pre-algebra is a fancy word for fraction. And it's a ratio that compares the amount of change It's a ratio, fraction, that compares the amount of change in dependent and independent variables. And we've found the rate of change already. We just haven't called it the rate of change. But you found the change in y over change in x. That's seeing if there's a slope. That's finding the rate of change. For every $3 you sell one candle. For every 3 children you babysit, you make $10. Right? It's the change. It's looking at the increase in one and comparing, seeing if it has an increase in the next one. Do they affect each other? So you've already used change in y over change in x. A way of shortening change in y over change in x, especially in physics, the Greek letter delta, which is a triangle, means change. So delta y over delta x means the change in y over change in x. The Greek letter delta is used for change. So let's make this table really quickly. So we've got years and we've got costs. In 1988, the cost was $25. No. I was born before 1988. Yes, good math skills. I am older than that. 1990. It went to 25. Stayed the same. From 1990 to 1991, it was 29. $1992 went to 37. And in 1993 to 41. So we're going to look at our change in y over change in x. And in any table, X, Y. That's the way that it works. The year is our independent. It cannot be changed. We have no control over what year it is. The cost can be changed. It's different everywhere else we go. That's the dependent. The cost depends on what year it is. So let's find our change in Y. From 25 to 25, what happened? 0. I'll change colors. And from 88 to 90, what was the change? +2. Then we're going to find the change in Y from 25 to 29. 4 plus 4, positive, right? The plus doesn't really need to be there since it's positive. If it was a negative, we'd put the negative sign. Over from 90 to 91. 1. Dylan, you need to be writing this down. Talon, do you have your notebook out? Okay. From 29 to 37, what was the change? +8. And from 91 to 92, what was the change? +1. From 37 to 48, what was the change? +4. And from 92 to 93, what was the change? All right, so we've done this step before, correct? We've even done it to the point of saying that is this graph going to be linear or nonlinear? Nonlinear. Because these are all different. These 4 things that we found are called the rate of change. Those are the rate of change. They're not called slope, because if it was slope, they'd all be the same. Slopes are all the same. Rate of change can all be different. So which rate of change was the greatest? From 91 to 92, that was the greatest rate of change. I could simplify that to say it's 8. Simplify to make 4, 4, and 0, right? My greatest rate of change was 91 to 92. If I was going to graph that, which way, like if I was going to graph, do you think a greater rate of change is steeper or flatter? Steeper. This part of the graph, if it was a picture, you know, they'd all be going up, but this one would go up quite a lot. It would have a drastic, more incline. Remember, when simplifying, no mixed numbers. When you simplify, no mixed numbers. So if you're given a table, you can find the rate of change. You can also determine if there's a slope, because if it's linear, they're all the same. It's called a slope. If it's nonlinear, it's called a rate of change. So let's do that. Linear is called slope. They're all the same. Linear is called slope. They're all the same. Nonlinear is rate of change. They're different. Maybe all of them are different. Maybe everything's the same and there's one that's different. But if they're linear, they're all going to be the same. If they're nonlinear, they're going to be different. So to find the rate of change or the slope, depending on which one you're looking at, in a graph. So from a graph. We're going to measure the steepness of a line, or maybe it's a segment. If it's nonlinear, it's going to be a segment. If it's linear, it's going to be a line. So from a graph, we measure the steepness of that line or of that segment. And to do that, you need to have two dots. You need to have two dots on the line. I'm not going to make that one. I'm going to make it a star. You need to have two dots on the line. You start at the bottom dot and count up. Start at the bottom dot and count up. Turn the corner and count over. It's up, then over. Don't do over and up. It's up, then over. Two dots. Start at the bottom dot and count up. Turn the corner and count over. That'll make sense in a second. Here's the formula. Rise over run.
At this time,
okay, rise over run. Rise going up is a positive number. If you ever go down, it's a negative number. That makes sense, right? Going up is positive, going down is negative. If you go to the right in your run, if you go up and then you turn the corner to go to the right, that's a positive number. What if you go to the left? Negative. It's a negative number. Okay, really quick. They're going to be ugly graphs. It'll be okay. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Right? If we go over 1 and up 2 to that dot, and my other one's at -1, -1, there's a line. You start at the bottom dot and count up 1 space, 2 spaces, 3 spaces. Turn the corner and count over 1, 2. There's your slope. That's your rate of change, your slope. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Go -2, +1. Go 1, -1. Start at the bottom dot. Count up. 1, 2. Count over. 1, 2, 3. But it's not 3, it's -3. Here's how I remember it, ladies and gentlemen. If you're looking at a graph, a negative slope will make the letter N. It's going to have a negative slope if that line is the diagonal in the letter N. This one over here is positive. That's not the diagonal in the letter N. Let's do 2 more lines. I'm just going to draw them like this, not on a graph. In this horizontal line, which one's on bottom? I mean, they're both at the same level, right? So how many spaces do you have to go up? 0 over, and let's pretend it's 1, 2, 3, 4. 0 over -4 is what? 0. If I'm looking at this graph, which is a vertical line, can you tell which one's on top or which one's on bottom? Yeah. I go up 2 spaces. But how many spaces do I go over? It's undefined. You cannot have 0 on bottom. Elementary school, I learned this. It's okay for 0 to be on top, but no way can 0 be on bottom. If 0's on bottom, it's undefined. This gets glued on the next page. Mr. Slope, look. This direction has a positive slope. This direction has a negative slope. His nose is vertical, so it's undefined, and his mouth is horizontal, it's 0.